In the previous video, we talked about the technique of partial fractions, but in the examples that we did, the denominator was factored into two factors. But sometimes the denominator has more than two factors. So the denominator has more than two factors. For example, it could have three factors. To make the examples manageable, we do examples that the denominator is factored into three factors. The idea is very similar, but instead of making the rational function into two fractions, we make the rational function into three fractions. So let's see an example here. So using the technique of partial fractions, we want to do this integral. This is a rational function, and the denominator is of degree 3. It's x cubed minus 4x. As you might remember from the previous video, in step 1, we write this rational function, 6x plus 8, or any rational function that we dealt with, as we saw in the previous video. We break this down into some fractions, but the denominator of those fractions are the factors of this denominator. So you know that this x cubed minus 4x, if I fully factor this, so first of all, x is in common, I can factor that out, x times x squared minus 4, and x squared minus 4 can be factored as x plus 2 times x minus 2. So knowing this, we can break down this fraction into the sum of three fractions. One of them with the denominator of x, one of them with the denominator of x plus 2, and one of them with the denominator of x minus 2. In the previous video, we broke down the rational functions into the sum of two fractions because the denominator was factored into two factors. But here we have three factors. Therefore, the rational function can be written as the sum of three fractions. Now I should determine what numbers a, b, and c will be the numerators of these fractions. So in step 1, we try to figure out what are a, b, and c. So first of all, similar to the previous video, we get rid of the denominators on both sides by multiplying both sides with the denominator of the left. So let me rewrite what we have so far. So far we have 6x plus 8 over x cubed minus 4x. And as we know, x cubed minus 4x is factored as x times x plus 2 times x minus 2, as we saw here. So this was equal to, let me make some space because I want to multiply something by both sides. A over x plus b over x plus, I'm sorry, b over, excuse me, b over x plus 2 plus c over x minus 2. So I multiply both sides by x times x plus 2 times x minus 2, which is the factorized form of x cubed minus 4x. So on the right side, I have three terms. Each of these three terms is multiplied by the same thing, x times x plus 2 times x minus 2. So x times x plus 2 times x minus 2. Let me make this a little bit clear here. So x times x plus 2 times x minus 2 is multiplied by the first term, a over x, plus the same product, x times x plus 2 times x minus 2 is multiplied by b over x plus 2, and then plus the same product, x times x plus 2 times x minus 2 is multiplied by c over x minus 2. Okay, now let's make the obvious simplifications here. You know that this product is the same as this denominator, so they cancel out. On the right side, the first term here, x from the top and x from the bottom, they cancel out. In the second term, x plus 2 and x plus 2 cancel out. And in the third term, x minus 2 and x minus 2, they cancel out. So let's see what we have so far. From the left side, we have 6x plus 8. On the right side, the first term is x plus 2 times x minus 2 times a. The second term is x times x minus 2 times b. And the third term is x times x plus 2 times c. As you know, x plus 2 times x minus 2 is x squared minus 4. X times x minus 2 is x squared minus 2x. And x times x plus 2 is x squared plus 2x. So 6x plus 8 is what? I can distribute this a over the parentheses here. So I will have ax squared minus 4a. Then I can distribute this b over this parentheses, bx squared times b times 2, then minus 2 times bx. So in other words, I will have bx squared. B times minus 2x is going to be, uh, excuse me, bx squared. Bx squared. B times minus 2x is going to be minus 2bx. And finally, I distribute the c over the parentheses, which gives me cx squared plus 2cx. Similar to what we did in the previous video, but of course, uh, those examples were shorter than this example. We try to write both sides in the standard form and then set the corresponding coefficients equal to each other. So let's see, on the left side, I have, let me continue on the next page, 6x plus 8 equals, on the right side, I see that three terms are of degree 2, ax squared, bx squared, cx squared. All of them have x squared in common. I can write that as a plus b plus c times x squared. Now, there are two terms which have only x, in other words, are of degree 1, these two. So x is in common. What I can do is I can factor x out. So this is going to be minus 2b plus 2c times x. Let's see if anything is remaining. Yep, minus 4a. This minus 4a is remaining here. And at the end, minus 4a, or plus minus 4a. On the left side, I don't see x squared, but on the right side, I see x squared, and these two should be identical. So I can assume that on the left side, in fact, we have a 0x squared. We had a similar situation when we did one example in the previous video. Now, the corresponding coefficients are equal, meaning that the coefficient of x squared on the left, which is 0, and the coefficient of x squared on the right, which is a plus b plus c, they are the same thing. So the first equation that I get to find a, b, and c is a plus b plus c equals 0. The coefficient of x on the left side is 6. The coefficient of x on the right side is minus 2b plus 2c. So minus 2b plus 2c equals 6. And the coefficient, the constant coefficient, or the coefficient which has no x, on the left side is 8. On the right side is minus 4a. So minus 4a is 8. So we need to solve this system of equations, three equations in three unknowns. This is a kind of simple equation because simple system of equations because the last equation already gives me the value of a. Minus 4a is 8, dividing both sides by minus 4, a is going to be minus 2. So I already found a. How about b and c? So in the first equation, look at these two equations now. In the first equation, I already know that a is minus 2. So minus 2 plus b plus c is 0. In other words, b plus c is 2. If I add 2 to both sides, b plus c is 2. The second equation, minus 2b plus 2c is 6. So that system of equation, b plus c equals 2. By the way, in the second equation, minus 2b plus 2c equals 6. All the coefficients are divisible by 2. So I can divide both sides by 2. So I will have minus b plus c equals 3. Using any method at your choice, you can solve this system of equation. Or if I add these two equations up, left side added to the left side and right side added to the right side. B and minus B cancel out. C plus C2C, and on the other side, 2 plus 3 is 5. Now divide both sides by 2. C is 5 over 2. And 5 over 2 cannot be simplified more, so it remains as 5 over 2. I found C. Since B plus C is 2, I can easily find B. So this is kind of problems you have seen in basic algebra courses. So B plus C is 2. C is already 5 over 2, so B must be minus 1/2. So from step 1, let's see what we have already found. We have found that 6x plus 8 over x cubed minus 4x is a over x. We found that it was minus 2 over x plus b over x plus 2. B, we found that it's minus 1/2 over x plus 2. And plus c over x minus 2. C we calculated as 5 over 2 over x minus 2. Step 2 is the integral step that we integrate both sides. So the left side, in fact, is the integral of the left side is the question that we are working on. So the integral of 6x plus 8 over x cubed minus 4x dx. So that fraction is the sum of those three fractions. So the integral is the sum of three integrals. Integral of minus 2 over x, integral of minus 1/2 over x plus 2, and integral 5 over 2 over x minus 2. From the first integral, minus 2 can be pulled out. So minus 2 times the integral of 1 over x. From the second integral, minus 1/2 can be pulled out. And from the third integral, 5 over 2 can be pulled out. It's a constant, so that's why it can be pulled out. So the integral of 1 over x minus 2 dx. In the beginning of the previous video, I reminded you about the integrals of the form of 1 over x or 1 over x plus k. Based on that reminder, we can have the final answer. Integral of 1 over x is ln of absolute value of x. Integral of 1 over x plus 2 is ln of absolute value of x plus 2. And the third one, 5/2. Integral of 1 over x minus 2 is ln of absolute value of x minus 2. And at the end, plus c, because it's an indefinite integral. And that's the final answer to this example. Okay, let's do another example. I would recommend that you pause the video and try to do this example on your own before watching my solution. So in the next example, we want to do the integral of 60 divided by x cubed minus x. So in step 1, we try to write this irrational function as the sum of some fractions. You know that x cubed minus x. So remember that x cubed minus x can be fully factored as what? First, I factor x out, x times x squared minus 1. And that can be factored as x times x plus 1 times x minus 1. So this can be written as the sum of three fractions. The first one with the denominator of x, the next one with the denominator of x plus 1, and the third one with the denominator of x minus 1. And I need to determine what are the constants a, b, and c. So I multiply both sides of this equation by x cubed minus x, or by x times x plus 1 times x minus 1. X cubed minus x in the factorized form is x times x plus 1 times x minus 1. So I multiply both sides by x times, let me do that in the next page. So I multiply both sides by x times x plus 1 times x minus 1. So the left side was 60 over x cubed minus x. The same thing is multiplied by all the three terms on the right side. X times x plus 1 times x minus 1 is multiplied by a over x. X times x plus 1 times x minus 1 is multiplied by b over x plus 1. I don't have enough room on the right side, so let me continue here. Plus the same product of x times x plus 1 times x minus 1 is multiplied by c over x minus 1. Now let's simplify as much as possible. On the left side, our job is quite simple because all of these and these, they cancel out. They are the same thing. On the right side, that product times a over x, x and x cancel out. The next term, x plus 1 and x plus 1 cancel out. And the last term, x minus 1 and x minus 1 cancel out. So let's see what we have. On the left side, you only have 60. Then x plus 1 times x minus 1 times a. Then x times x minus 1 times b. Then x times x plus 1 times c. We know that this is going to be x squared minus 1. This is x squared minus x. And this is x squared plus x. So 60 equals, this a is distributed over these parentheses, ax squared minus a. This b is distributed over the next parentheses. It's going to be bx squared minus bx. And this c is distributed over these parentheses. Gives me cx squared plus cx. Okay, now I can combine the like terms on the right side. Ax squared, bx squared, and cx squared, they add up. Let me continue on the next page as a plus b plus c x squared. Minus bx and plus cx, x is in common, so that gives me minus b plus c times x. And just minus a by itself is the constant part of this polynomial, plus minus a. On the left side, we had only 60. but I want to compare the corresponding coefficients. I don't see anything like x having only x on the left side, so I can assume it is 0x. I don't see anything as x squared, so I can assume that this is 0x squared as well. Now the corresponding coefficients are the same, are identical, meaning that 0 is a plus b plus c, so that will be the first equation of this system of equations. This 0 is the same as minus b plus c, so minus b plus c is 0 as well. And 60 is minus a. So minus a is 60. The last equation is quite simple because if minus a is 60, a itself is minus 60. So this is a. Now we want to find b and c. So in the first two equations, if a is minus 60 plus b plus c is 0. In other words, b plus c is 60, and minus b plus c is 0. So this system of equations of two unknowns, b plus c is 60 and minus b plus c is 0. If I add up these two equations, b and minus b cancel out, c plus c is 2c, 60 plus 0 is 60. And if you divide by 2, c is going to be 30. Since b plus c is 60 and c is already 30, it gives me that b is also 30. So step one tells me that fraction, 60 over x cubed minus x, is equal to what? Is equal to a over x, and we calculated a here is minus 60, minus 60 over x. B over x plus 1, we calculated b, it was 30, 30 over x plus 1, plus c over x minus 1, 30 over x minus 1. C was also 30. Now, step 2, which is the step that gives us the final answer, the integral of 60 over x cubed minus x dx is the integral of minus 60 over x plus the integral of 30 over x plus 1 plus the integral of 30 over x minus 1. In the first integral, minus 60 is a constant, comes out. And integral of 1 over x is ln of absolute value of x. So in the first integral, we just pulled out minus 60, which was a constant. And integral of 1 over x is ln of absolute value of x. In the second integral, 30 is a constant, can be pulled out. And integral of 1 over x plus 1 is ln of absolute value of x plus 1. In the third integral, 30 is a constant, comes out. And integral of 1 over x minus 1 is ln of absolute value of x minus 1. And at the end, plus c. Plus c because it's an indefinite integral, so we need a plus c at the end. So that's the final answer to this example.